Did anybody come up with a good answer for this? Anyone? Good answer that they want to share? Type 1 error? Anybody? No?
It's a type 1 error when the null hypothesis is rejected, but it's true.
Yep, exactly. Perfect. And then type 2 error, anyone? All right, no worries.
Type 2 error is you fail to reject the null hypothesis when it is false.
Yep, totally. Perfect. Well done, guys. Here's some other answers that people have given in the past, which are pretty similar to what you guys have just said. Type 1 error is when you get lucky, or maybe say unlucky. Could be when you get unlucky and you just have an unusual sample, right? So you don't realize it, but you just have gotten lucky or unlucky and got an unusual sample. Or when you reject H naught when it really isn't unusual, which is kind of what you guys just said. Type 2 error is, like you said, when you should reject the H naught, but you don't. In other words, it's when your mean is different, but it's not different enough to trigger that unusualness. Okay. I just want to go over a couple more things and we'll take a break. The first one is, this is the rest of that page, the critical read. Why am I reading this? Amanda, have you read yet? Can you read?
Yeah.
Thank you.
The critical or rejection region is the range of values of the test statistic that are unusual, so the null hypothesis should be rejected. The non-critical or non-rejection region is the range of values of the test statistic that are usual, so the null hypothesis should not be rejected.
Perfect.
The critical value, CV, is the z-value that separates the critical region from the non-critical region.
Exactly. So we kind of like to, often we'd like to call it guilty and not guilty. So this would be the not guilty region. So this is the critical region where we say that they're guilty. So everything over here, kind of from here on out in this direction, we would say that those guys are all guilty. So over here, totally guilty over here. And then over here on this side, this would be the non-guilty region, anything over here. So depending on what your z-score is or your test stat, you're either going to be in the guilty region or the non-guilty region. This borderline right here is between the guilty and non-guilty region. That's our critical value. We get that from our table. It's something that's fixed and permanent. It has nothing to do with our sample. It's fixed and permanent depending upon our alpha. We look at our alpha. Based on our alpha, we look up on the t-table or the z-table and figure out what our critical value is. And then we pop it in. So this has nothing to do with our sample. It's based upon, just upon alpha. What's unusual or not unusual based upon alpha. Look up the critical value from the t-table or the z-table, depending. And again, if you're bigger or further out than your critical value, then you're unusual. This is the unusual range over here. If you're not anywhere in here, then you're not unusual. And we kind of like to think of it as guilty and not guilty. So sort of like so right here, right? This guy sure looks guilty, right? But we don't have enough evidence to say that he is guilty. We don't have enough evidence to reject the null hypothesis. It may be true, right? And maybe we should reject it, but we don't have enough evidence to prove it. So we kind of think it's kind of like OJ, right? He looks guilty, he seems guilty, but I don't have enough evidence to say for sure that he's guilty. So here we would say that, we wouldn't say he's innocent, but we would say that he's not guilty, right? We can't prove he's guilty. Because remember, people aren't proven innocent, they're proven guilty or not proven guilty. And then this on your sheet, I would say the critical value, right? Again, I talked about that a second ago, based entirely upon alpha. But what I want you guys to do is don't worry about this part here. Cross that out of your notes and just circle this part here. Use the t-table, degrees of freedom, infinity. If you're talking about the z-score, just use, remember the z-score is the last row of your t-table. It's when your degrees of freedom is infinity. That's your z-scores. That's your z-table. The juice, OJ. It's so funny. Okay. Oh, I like this thing from Eduardo. He said type 2 is when one does not reject the null hypothesis when it is wrong. Perfect. Nice. Okay, so I think we're good for now. Let's go ahead and take a break for 10 minutes. We'll come back at 8:44. So take a little break, and we will head and start up again. We're going to take a look at, so now we're on our 8B handout. So everyone go to your 8B handout, and we're going to start in with that. This is the very beginning, the very top stuff, the very first part of your 8B handout is right here. Let's get a reader. Sarah, you're just on. Go ahead and read this part. So read the stuff on the right and then read the stuff on the left.
Okay. H naught is mu equals to mu naught, and H1 is mu is less than mu naught.
Great.
All A in the left
alpha, sorry, alpha. Alpha?
All alpha in the left tail.
Mm-hmm.
A contractor wishes to lower bills less than below and decrease.
Right. So this is, again, these are the guilty and not guilty regions. So not, oh, whoops. It's okay, no worries. So this is the guilty region. This is the not guilty region. The left tail test would be where everything's on the left side. The left tail is the guilty region. And it's when your H1 is going to be less than, right? Left tailed, less than. What kind of words, how do you know it's a left tailed? You look at the words of the problem. Look at the claim. The claim is lower, less than, below, decrease. Those are the words that tell you that this is a left tail test. That it's less than, that it's saying that your mean is less than everybody else's mean, or your proportion is less than the regular proportion. So that's the left tail test. That's the first thing, the very first top thing you're filling in off of your chapter 8B notes. The next thing is this one here. Sterling, can you go and read this one for us?
Right-tailed test, H naught. Mu is equal to mu naught. H1. Mu is greater than mu naught.
Great. Keep going.
All A.
Alpha, sorry. It's
all
alpha.
alpha in the right tail. And additive to increase the lights more than, greater than.
Right? So those are those clues. More than, greater than, increase. Those are the things that tell you it's a right-tailed test. You're saying that your mean is greater than, is more than everybody else's mean. So that means that the tail, the guilty tail is going to be on the right, and this is going to be the guilty area, the rejection area, and then the non-rejection area, the non-guilty part is over here. Two-tailed tests. Andre, you haven't read in a bit. Go ahead and read.
Two-tailed test, H naught, what the hell happened?
That was me, sorry.
Mu equals mu naught, H1 mu is not equal to mu naught.
Great.
Alpha is divided equally between the two tails of the critical region. Will the pulse rate remain unchanged? Is equals differs.
Right. So here we've got two guilty regions, right? We've got a left side and a right side, because we're saying that it could be that my mean is just different than the other one. So if my mean is different, it could be less than or greater than, either one. And here these are things like unchanged, or is, equals, differs. Differs means different, either less than or greater than. These ones here, is, equals, unchanged, that's when your claim is H naught. And again, when your claim is H naught, then your H1 is the opposite. So either of those will get you an H1 of not equal to, or a two-tailed test, when your claim is either differs, when your claim is not equals, or your claim is equals, is equals unchanged. So those are the ways you get a two-tailed test. And in both those cases, you're going to have H1 where the H1 is not equal to, so you're going to have a guilty region on the right and a guilty region on the left, and then the non-guilty region will be in the middle. I think is this on your notes? I don't know if it's on your notes, but just a reiteration that these unusual regions, right, the guilty regions, the rejection regions, are separated from the non-guilty by your critical values, critical value or values. And please note that you can just call them critical values. Your book will call them Z alpha over 2. That gets really confusing for people. And I found that when I just started calling them critical values, my scores went up a lot. Students did better because they weren't as confused by the Z alpha over 2. Just on the exam, in the homework, on the exams they'll be called critical values. And the homework, just remember that Z alpha over 2 is the same thing. It just means critical value. They're the same thing. And these are the exact same critical values that we had in Chapter 7. Those don't change at all. They're the same sort of idea. We get them from the table. They're all from that table. Finding it for a Z distribution. So again, when do I use a Z distribution? Sometimes I use a Z. When do I use a Z versus a T? Do you guys remember? Give you guys a little hint.
Use a Z when it's a circle.
When it's a circle?
Circle.
Wait, did I see me again?
I said use the Z when it's a sample.
Oh, well, you're always going to have a sample. So there'll be a sample always. I know it gets confusing. You're always going to have a sample, but, yeah, like Gina said, easy peasy, use Z's for proportions. Mean Mr. T means you use, you have mean, you use T. So, again, this is just a way to remember that. Easy peasy, which one has a Z in it? The easy peasy part. So that's my hint. That's just a mnemonic to help you remember that. Ooh, that's really big. That's too big. That when you have a Z distribution, use a P. When you use a Z distribution is when you have a P, a proportion. So proportion would be when you have a Z distribution, so proportions. Proportion, again, is when your data is yes, no's, right? It's a percentage. Proportion is 3 out of 5 dentists prefer CREST, recommend CREST. That's a proportion. And the best way to use them is to just look it up on the T-table, but remember it's going to be degrees of freedom is infinity because the last entry of your T-table is a Z-table when degrees of freedom is infinity. Don't bother with these because the issue with them is that people get confused about when you divide by 2, when you do not divide by 2, and people get screwed up. If you want to, you can, but my recommendation is to just stick with option 1 because it just makes things easier and less confusing, unless you're totally all over it. So then you can. It's totally fine. For a T distribution, again, when do you use a T distribution? In which cases will I use a T distribution?
When you have the mean.
Yep. When you have a mean. Mean Mr. T. So Mr. T isn't mean, but he looks mean. So when you have a mean, you're going to use a T distribution. So you're going to use it when you have a mean. And here, you're going to use, look it up on the T-table, using degrees of freedom of n minus 1. And then pick the correct sign. If it's right-tailed, it should be positive. If it's left-tailed, if you look at the T-table, the T-table gives you everything in the T-table is positive. They're all positive because they just want to give you the numbers. You can figure out the signs on your own. So if it's left-tailed, you know that anything that's on the left side of a normal distribution curve should be negative, right? All those z-scores are negative, so you just make it negative. If it's two-tailed, then you have a positive one and a negative one both. And again, I would recommend you not use these ones because people get confused about when to divide by 2 and when not to, and they do it in inappropriate times all the time. So just keep it simple. Critical value, look it up on the table. We'll go over those later. So go ahead and why don't you, I'll bring up the t-table in case you guys need it, but I want you guys to take a minute and find these, and these are all for z-scores. These are all for z, so you're going to use the bottom row for all these. So go ahead and find them. I'll move this over a little bit more, maybe. Or not. Jeez, impossible. Oh, we'll do that. There we go. That'll work. Okay, so let's go ahead and take a look. For alpha's 0.05, left tail, that's one-tailed. So alpha's 0.05, one-tailed. That's this one right here. So again, we're going to go all the way down. Oops. And we're going to look at the z part of it, 1.645. 1.645. Or you could make it, it's just negative. It's left tailed, so it should be negative. You could round it to 1.65. So again, left tailed should be negative. If you didn't make it negative, keep that in mind. It should be negative. Negative 1.645 or negative 1.65 if you want to round it. For alpha is two-tailed, 0.05, two-tailed, that's this one here. So that means we're going to use this number down here, 1.96. And again, that can be positive or negative. So here that's going to be negative 1.96. Comma positive 1.96. You're going to have two of them. And then the next one, take a look. We've got alpha's 0.005, right-tailed. So this is again one-tailed. Right-tailed is one. Right and left are one-tailed. So one-tailed test, 0.005. There we go right here. It's going to be this guy right there, 2.576. So that would be ours for that one. And it's right-tailed, so it's positive 2.576, or you could just put 2.58. That's fine too, round it to 2 decimal places. I see 3 sig figs here. All right, going to close that up. Are there any questions on that one? Everybody good? All right, so go ahead and write these in. This is the rest of that front sheet. Go ahead and take a minute and write out what you write stuff out. Write these out. I'll go ahead and describe them a little bit. So first one, step 1, I say the hypothesis and identify the claim. You guys have been doing that the last 2 classes. I feel like you're really comfortable doing that, hopefully. Step 2, find the critical value. You're going to do this by looking up in the t-table. Look up in t-table. That's where you're going to get that one from. And then it says draw a picture. So you're going to draw your picture here. You're going to put in your critical value. Say it's 1.96, for example. And then you're going to shade the rejection region, the part where you would reject H naught. So you shade over there. So that's what you do for part 2. Look up the critical value in the t-table or your z-table, which is the bottom row of your t-table, and then draw a picture. Put in your critical value, maybe label it, would be good, and make sure you shade the rejection region, because otherwise when you put in the test stat, it's going to be unclear which one, whether it's what region it's in. So right away, find that. So this, again, this has nothing to do with your sample at all. This is just before you even take the sample. Step 3, then you check the sample out and you find your test stat, and then you pop it in wherever it belongs. And maybe it goes in here, and that's your test stat. And you write in the amount there. And then you make your decision. So your decision is going to be one of two things. It's either going to be reject H naught, or it's going to be do not reject H naught, depending upon where it falls in the rejection region. So here in this case, would I reject it or not reject it, this guy? Is he in the rejection region or is he not in the rejection region? He's not, so we would say do not reject H naught in this case. Everybody good with that part? And then the last thing is summarizing results for the claim. So this is all about the claim. Results for the claim. Because at the end of the day, when you finish up and you finish up your stuff and you go home, you're not going to say to your mom, hey, or your sister or your friend, whoever, I did this great test today. We did all this stuff. Oops. Oh no. That's a bad sign. Oh. Okay. If you were going home to your family, you wouldn't say, oh, hey, we did this great test and I rejected H naught. They have no idea what you're talking about. You'd say, oh, I did this great test and I found out that, it really is true that, the proportion of people who like rock music is more than 80% or something like that. You'd state what it is in terms of your claim. And again, R for reject, that goes with H naught because rejecting H naught rejects your claim if H naught's your claim. And S for support goes with H1 because rejecting H naught supports your claim. Right? Rejecting H naught is good for your claim. All right, let's see if we can clear that. Clear all drawings. This is going to be a little different. All right, so now we're going to take a look at an example. Let's get, Jocelyn, can you read this one for us?
Example, obese young people. A researcher claimed that based on the information obtained from the Center for Disease Control and Prevention, 17% of young people ages 2 to 19 are obese. To test this claim, she randomly selected 200 people ages 2 through 19 and found that 42 were obese. At a 0.05, is there enough evidence to reject the claim?
Perfect, thank you.
Step 1.
Oh, no, that's okay. That's good. All right, so the first thing is, let's take a look and figure out what our stuff is here. So let's figure out our claim. Researcher claims, based on information, that that she's claiming that 17% are obese. So 17% are, so it means that my claim is that first of all, is this a proportion or a mean? How do I know that it's what it is? So take a second, is it proportion or a mean, and how do we know? Proportion, Gina says proportion. Proportion because it's yes, no. Either you are or you aren't. Felicia says proportion also. This is the easy way to tell. All right, so if you're not sure, this is how you tell easily. Find in this sentence the word mean or the word average. Average is another word for mean. So look through here and find the word mean or average. You guys see the word mean or average? Anywhere in here? Not there. Mean or average. Mean or average. There's no word mean or average. If it's a mean, then I have to give you the word mean or average somewhere in there. I have to say mean of or average of, which is another way of saying mean. So if I don't give you the mean, if there is no mean, it's a proportion. That's how you know it's a proportion. So that's the beauty of this, is the absence of the word mean or average means it's a proportion. So what's my claim? Ooh, this is weird. My claim is that the proportion is equals 17%, 0.17. That's my claim. Can I write down claim? Claim. Good. Great. So then the next thing we're going to do is we're going to take a look and say, oh, my H naught is always equals. So here it's going to be P equals, whatever this is, 0.17. Are these the same? Yes, they are. So then H1, in this case, since H naught is my claim, H1 becomes the opposite of my claim, not equals. P is not equal to 0.17. Now, here's the deal. If I reject H naught, what does that do for my claim? Is that good for my claim or bad for my claim? Rejecting H naught, since this is my claim, rejecting H naught rejects my claim. So that's why I'm going to use the word reject here. I'm just going to make a note of it so that I know that that's the word I'm going to use and pull in when we get to step 5. This is your note. So you should be writing this down here. Step 1, you should be writing 1, and then you should be writing in H naught and H1, and then writing down claim next to H naught and writing down reject in parentheses next to H naught. This is the part you're turning in and putting into uploading. Step 2, find the critical value. Oh, I can change the size. Okay, good. Step 2, find the critical value. Since alpha is 0.05, the test is two-tailed test. I'm going to look at my handy-dandy z-table, and I'm going to say, okay, 0.05 two-tailed, proportion all the way to the bottom, 1.96. Great. So 1.96 positive, negative, so because it's two-tailed, and then I'm going to draw myself a nice little picture. So where's my annotate? So then I'm going to draw a nice little picture here. Maybe not such a nice picture. And I'm going to have left side and right side. And I'm going to put in negative 1.96 and positive 1.96. So you should have that in your drawing. You should have that drawn out next to that. So hopefully you guys have done that. And then we're going to move to step 3. You guys ready for step 3? Yes, no? Okay. I'm going to clear that. Now we're going to move on to step 3, which is computing the test value, the test stat. So my test stat is, okay, so let's look at this. Researcher claims that based on the information, blah, 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 blah. Okay, good. So my claim is 17%. That means that that's my P. My P is whatever I got in my claim. So my P is 0.17, which means that my Q is 0.83. That has nothing to do with your sample at all. Absolutely nothing to do with your sample. Your P and Q are from your claim. So find your P and Q first, and then figure out what's your sample. Let's see, my sample, randomly selected, that's the sample part. I'm going to use a different color than that. That's not good. Format, red. Randomly selected. So if you find the word sample, selected, surveyed, that's your sample. 200 people, that's my N. And then found that 42 were. So then my P hat is going to be 42 out of 200, 0.21. So then I need to figure out my test stat. So I'm going to do test stat is equal to my P hat, 0.21, what I got, minus what I expected to get, 0.17, divided by square root of 0.17 times 0.83 divided by 200. And you will end up getting, I think it's 1.51 is what we got. So then you'll go ahead and stick that. You guys good for me to move on?
Got it.
Okay. It's also going to be in the video, and it will also be on the PDF board work that I'll post from another class, not from ours, but it'll be in there. So then we'll take a look at the next slide, and I'm going to clear off this one. And you'll see here that here's my drawing, here's my rejection regions, and then here's the 1.51. So based upon that, it's in the non-rejection region, right? It's in the innocent region, or the non-guilty region. So I'm going to say, do not reject H naught. So do not reject H naught. And that's all you have to do. You don't have to put all these other words, you don't have to put that. Just put this right here. That's your step 4. That's it. Done. Step 5. Now step 5 gets a little bit tricky. So this is where we need to pay attention. Step 5. Everything in black down here is kind of fixed. You're always going to say there, blank, not enough, there, blank, enough evidence to blank the claim, and then whatever the claim is. Just reiterate the claim. The claim that blah, 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 blah. Right? Whatever it is, you have to say it. Just spell it out because it's important. Okay. Now you're going to look at these two pieces here. The first piece is, it's too thick, is this reject. Reject comes entirely from step 1. Step 1, if H naught is claim, then you're going to use reject. If H1 is your claim, then you're going to use support. And that's all that is to it. That's it. There's nothing fancier than that to this part. All right. So that's where this part comes in. This one over here, pick a different color. Oops. Maybe I should move that down a little bit. Okay, that's fine. This part over here is all about step 4. So this one depends entirely upon this part right up here. If you have enough evidence, then you'd say either if you rejected, you have enough evidence. If you did not reject, you did not have enough evidence. So step 4, reject H naught, then you have enough evidence. Don't reject, not enough. So that's basically, that's where that part comes in. Let me get this somewhere where you can see it. All right. Is that clear as mud? How you guys doing with that? So again, this part here is basically just upon step 1. Which one's your claim? If H naught's your claim, then use the word reject. If H1's your claim, use the word support there. Because again, rejecting H naught rejects your claim. If H1's your claim, then rejecting H naught supports your claim. This one over here, step 4, determines this one. If you rejected H naught, then you had enough evidence. If you did not reject H naught like we did not have enough evidence. Okay, everybody okay to move on? Okay, again, this will be on the BoardWork PDF, and it'll also be on, it'll also be on the other thing. So let's take a look. Female gun owners. Let's do this one together. I'm just going to stop this for a second. Let me get someone to read this.